All right, this is a brief review of the question we left off previously about how to do a multi-step problem that required getting the volume of a block and then a unit multiplier to change units. The difficult part about this is you guys may be struggling to identify where to even start. So first of all, unit multiplier is needed when changing units from one measurement to another. So you have to have some sort of quantity to start off with first. The only thing I have in my possession right now for the problem at the top of the screen, which is from the worksheet we worked on the other day, are the lengths of the block. So right off the bat, the first thing that dawns on me to do is to determine the volume of that block, and then I can work with volume relationships or length relationships to cancel the volume out. Now the original question says, estimate the mass of the block in kilograms. You guys have to remember that if you're giving something with volume and mass, the connection is density. So without density, you won't be able to make that jump between volume and mass. But since I want mass and I know volume's a way to get there, I'm going to determine the volume of this block. So I want you guys to show your work. Technically, doing volume is probably something you can go ahead and just type out because there's no unit canceling. So maybe I'll demonstrate just typing this out right now. (24.5 inches). I'll use the asterisk for multiplication, times 12.2 inches times 1.5 inches, all get given on the diagram. You guys multiply those, you get volume, which is a basic mathematical strategy. I'm going to round to the tenths place since all my data was originally only to the tenths. 448.35, but I'm going to round that to 0.4 inches cubed. To make sure you keep your units squared away, either they're lengths or squared or they're cubed. All right, now I'm going to use the drawing tool and I'm going to go on and I'm going to estimate the mass. But you guys have to realize you're in inches cubed, which is an English unit. I need to get to the metric system. Luckily for us, some common knowledge relationships are on the right. 1 inch for every 2.54 centimeters. So I'm going to use this relationship to get out of the inch family into the metric system of centimeters cubed eventually. I'm going to do that because I know densities are written in cubic centimeters typically. So 448 0.4 inches cubed. Multiplied by 1 inch in the denominator. And I'm just going to round it, make it easier, 2.5 centimeters in the top numerator. But remember, this inch in the denominator is only a length. The inches cubed is a volume. So this denominator inch only cancels one of the inches in the numerator back with the 448. There's still a square inches in the back. So I'm going to do this again using the same relationship. I'm probably writing a little bit big here. My mouse is overly sensitive for some reason, but this inch in this denominator cancels another inch back here at the beginning. Remember, it was inch cubed, so that's inch times inch times inch. I've only just canceled 2 of those inch units now out of the original cubed. That means I need to do this relationship one more time. And now this final inch in the denominator finally cancels all the inches back here on the original inches cubed. Now I'm in centimeters cubed once I complete this mathematical practice. Now, I'm going to try to go ahead and keep going. Some people might want to put an equal sign here and just get the volume in cubic centimeters, but I'm going to go ahead and try to keep going as best I can. So I know I'm in cubic centimeters because those are the units that are left over, but I want to get to mass. So luckily for me, I realized that cubic centimeters has a relationship to grams and mass for a density, and the density of this wood block is given above. For every cubic centimeter, there's 0.51 grams. So I'm going to tag on the centimeter cubed in the denominator. Now this cube centimeter back cancels to these previous centimeters in the numerator. Because these centimeters are times each other in the numerator, it's a cube. So that means this whole cube in the denominator cancels back. And then the rest of the relationship of this wood density, the 0.51 grams on the numerator. So that was pretty straightforward. Now I'm in grams, but here's the problem. The problem wants it in kilograms. So I'm going to tag on one more unit multiplier using some common knowledge information. That is not given in the problem for some reason here. You just have to know that for every kilogram, there's 1,000 grams. That means I'm going to put the 1,000 grams in the denominator because I want the grams previously to cancel for every 1 kilogram. Show those swiping, canceling. Now I'm in the units of kilograms. If you guys go back to the problem, we wanted units of kilograms for mass. We can now execute the mathematics. So remember, when you multiply these, you multiply the 448.4 all the way across the top of these numerators. And then you multiply just the bottom denominators all the way across and simplify. Do not bring the 448 to the denominator. Do not multiply 448 times 1. So if I do this, I'll do it live. 448.4, and I'm going to multiply across top at 2.5 times 2.5 times 2.5 times 0.51, technically times 1 kilogram, and I get 3,573. And I'm going to go ahead and round it because I got too many decimals here. I'm going to round it to the tens place, since that's what we started at up here with the 448. I'm going to round it to 2 kilograms. But now you need to multiply the denominator. So 1 times 1 times 1 times 1 times 1,000 is 1,000. And it's a naked number because the units got canceled. So let's go through the simplification on the calculator. So we should be somewhere around 3.6, because I'm going to round it again, kilograms. Give this a quick review before we start our test.